We'll use Solid Edge to complete the enclosure of this heart rate monitor. Solid Edge with synchronous technology excels in sheet metal construction, allowing designers to efficiently work with surrounding components to define external product housings. In most CAD systems, the user has to modify a part independently from the overall product assembly. With Solid Edge, additional flanges can be created at the top-level assembly just by selecting and dragging the plate's thickness faces. No special command necessary. Medical device manufacturers must adhere to strict government regulations, and any gaps between panels could be faulted. Using the close corner command, these gaps are eliminated. The internal circuitry produces a large amount of heat, so normal operation of this monitor relies on cooling fans. To provide clearance for airflow, we'll define rectangular cuts on both sides of the enclosure. Synchronous modeling provides several methods to intuitively match the size of these openings to the shape of the fan assembly. Now that was fast and easy. Next, we need to create a locking tab for the enclosure's lid. Here we'll select the thickness face, but opt for a partial flange to create this tab. Using one of many handy options, we'll ensure its top is flush with the top of the part. We'll lock in a precise tab location using 3D dimensions. To meet safety requirements, simple rounds will remove sharp corners. The locking tab requires a starting slot, and Solid Edge needs only a sketch line to create the slot. We'll place a hole in the slot to complete the locking tab. We get the required clearance between the top of the locking tab and the lid by pushing the tab's top face deeper into the part. Another modification made easy. The locking tab needs to be stiffened, so we'll use the gusset command. Simply specify 2 gussets and Solid Edge automatically computes the spacing between them. Since an identical tab is needed to lock the lid on the opposite side, we'll quickly fence select and mirror these features to the other side. This completes the design of the enclosure's base. Now we'll create the lid. This is where the power of Solid Edge top-down design is realized. By constructing our housing in the context of surrounding components, we can ensure all holes align and mating parts match the first time, avoiding costly rework and eliminating scrap. As before, we'll create a new flange just by dragging the lid panel's thickness face to the length we need. On the front of the lid, we need a flange that wraps to the underside of the control panel. The contour flange command not only creates a more complex flange that will fit just right, it also allows us to close the inside corners too. Notice this bend radius doesn't match the rounded corner of the control panel. No need to access the history tree, just select the bend and change the radius. Again, that was easy. Remember the fans? Proper operation will require a vent on the side of the lid. We'll create this vent by sketching a rectangle to define the vent's extent and patterning a hole using the fill option. It's as simple as that. Notice that we have an interference problem between the lid and the front of the control panel. Applying a synchronous relationship will move the vertical flange flush with the control panel's thickness face. That was an easy fix. We'll finish the enclosure by mirroring this lid half around the thickness face of the part. Solid Edge facilitates creation of manufacturing information, often with little user intervention. Watch as we automatically derive a bend table from the lid model. Finally, we'll generate a flat pattern for use in a downstream manufacturing drawing. In this case, we'll insert the bend table and add a few coordinate dimensions. Direct interaction with surrounding geometry, coupled with industry-leading sheet metal design tools and innovative modeling capabilities, makes Solid Edge the choice for companies looking for an edge over the competition. Solid Edge. Design better.